Good morning, and so today we will continue with the the last part of machine learning, or the final slides of understanding data science and machine learning uh, conceptually, and then together we will work on the problem in the next session. So today I will introduce the problem. I will show you the methodology, one of the methodologies. You can apply different methods to solve a problem. I mean, we know that there is not only one solution to any problem. There can be many solutions, and one can work out and find the best solution for the problem. So that's the whole idea of this training session. So let me go back to the activation function today. So we already covered last time what is deep learning, and the types of neural network algorithm. There is supervised, unsupervised, semi-supervised, and reinforced. So, for example, you are passing the label data. You are passing this image in which there are four cars, four objects that then an algorithm is supposed to detect, and you label them as car. And four of these, let's say, cuboids are trucks. So you pass these objects uh, with label data, and that's what is called supervised algorithm. And in unsupervised, you don't provide anything. So there is this image without the labels, and the algorithm has to detect these shapes and learn from it. And we are going to see. So since you were asking in the beginning of this lecture, what is clustering? I don't understand that much. I know the terminology, but I don't understand it. So the clustering actually will help you if there are no labels. For example, if you remove these labels, it's going to detect these patterns, okay, and it's going to cluster them together. So all these four objects will be clustered into one. All these red trucks are going to cluster into another, and all the other, like for example, these pillars that you see, they're going to be clustered into another. This fence is going to be clustered into another. So, and also these road signs will be a different cluster. So uh, I mean, there is a way that you can actually learn from unlabeled data, but it's going to take more time to learn from it. And we are just going to see how the neural network learns from the learns from the data. And reinforced learning is something that uh, basically you offer a reward to the neural network if it has learned. If it has not learned, you basically offer a penalty. So that is something that you try to incorporate for this type of learning. And in today's like state of the art research, in Google and Spotify, all these YouTube, all these algorithms that they're working on, they are actually experimenting with reinforcement learning. So neural network architectures. We have already seen an architecture overall, but what is happening inside is there is a hidden state. There is an input state and output state. So X is input, O is output, and this is all the like vectors, the input vector, output vector, and the information that is passed from one state to another. So what is happening is these all states are connected to each other. Okay, these are like steps, same like one node passing information to another. Okay, and what happens is when you have an input information into a hidden state, it gives an output, and at the same time that output is passed to a next state, and that is an example of recurrent neural network. Okay, and in recurrent neural network, the information from the previous step is used as input to the current step, and that is why it is useful to process the sequential data. Unlike convolutional neural networks are just feed forward neural networks. Okay, there will be only, so this, imagine that this entire top section is not there, and it's just going to feed forward. Like, it's not going to use information from the previous state. It's just going to go on in the next step. This whole step is going to be in the next step without passing the information from previous step to next step. Okay, so that is something called convolutional neural network. So there are different architectures of neural network. We can't actually go through all of the architectures because there are so many that we can't cover it during the one training session. And even I don't know many of them which have been related or released through the research papers in the last few years. Because I mean, I know that there are transformers, for example, which is something like a transformer is something very recently developed by Google, and it was released in 2017. That was specifically targeted for language modeling. And even long short-term memories. These something those every neural network architecture has pros and cons, and to cover the cons of that particular neural network, the another architecture is imposed on that particular problem. So in case of transformers, these have already replaced recurrent neural networks in the market, and people now use transformers. And also LSTMs are like now conventional. People are using transformers, and multiple there are like various formations of transformers, like linformers or log formers. So we can go into the details or depths in a maybe a specific session which will be dedicated to only learning neural networks. Okay, but this is like out of scope of this session, so I'm not going to go in details, but understand the basic understanding is the information, there is one hidden state, and the information is passed from one state to another. Okay, so then there are activation functions. As I told you that from when you're passing an information from one node to another, so there is input layer, there is output layer, and there is information being passed through the number of hidden layers. Okay, and what is happening is each node is firing a function which is like a firing of neuron that is happening. And here in this case, there are different types of activation function which are used, which are valued between 0 and 1 or -1 and 1. And basically their job is to pass the probabilities from the input node to the output node, and that is why they are placed in between 0 and 1. And there are functions which are named as sigmoid, tanh. You can see the formula for those activation function here. And there's something called ReLU, and also there is one more type of activation function which is being used significantly in this field is softmax. You might also hear this word softmax. So that is also something that scales between 0 and 1, but only gets activated when there is actual detection of data or while training the data. So this is something that happens during the transfer of information from one node to another. And then of course there are different types of methodologies that are followed for solving a machine learning problem or data science problem. So you have to understand whether the problem is a regression problem or classification problem or clustering problem. Okay, so we have already seen in the previous So in supervised learning, there is regression and classification. In unsupervised, there is clustering. So there are different types of problems which use regression modeling. There are different types of problems which use classifiers. So we are going to, depending on the use case, you are going to use that particular method. So in this case, there is a regression model which is basically nothing but a fit to your data points.